and the new, I'll call it new, 472 kilohertz band. So as you can see, not exactly wide open spaces to play with. 2.1 kilohertz down on 136 and 7 kilohertz up on 472. So we have to cut our modes to fit our bandwidth. The interesting thing about 136 is that anybody can use it. Even a foundation licensee can come on 136. It would be a bit difficult because a foundation isn't allowed to use home-built equipment, but there are some commercial rigs. But one of the greatest exponents of 136 kilohertz in this country at the moment is a 2E0. And he does very well. So everybody can come on 136, well, you know, given the space and the inclination. 472 is only for your advanced licensee. We're probably most of the people in the room, but it might be, if you were really excited by the prospect, one of the few incentives for getting the making that big step up to the advanced license. So if you tuned into 472 or 136, what would you hear as a listener taking a dip in? Probably the most common thing on the band at the moment is whisper. I think just people just like to leave it running and burbling away and come back later and see where they've been heard. As you know, everybody knows about whisper. Next in the list I've put CW. It's probably not the next most popular thing, but it's still there. On 472 kilohertz at least, you'll find CW contacts. I have in the past, just when I was up in Scotland, took the 472 gear, banged out a CQ call one evening on CW, and I had QSOs for the rest of the evening. So it still happens. Mainly Germans and things. They seem to be keener than we are. Don't know why. You'll see I've underlined CW. Anything with an underline I'd call a QSO mode rather than a beaconing mode. The next one that's quite popular is JT9. You're probably familiar with JT65. JT9 is just a slower version. It sends for 1 minute and listens for 1 minute. And it's very much like FT8, which is the next thing on the list. People have tried FT8 on LF. It's not designed for LF. It's a little bit wider than we normally use, but you know, it's not. It still fits the. How wide is FT8? Does anybody have that?
6 hertz. 50 hertz? 50 hertz.
Yeah. So I mean, there is a constraint in the regulations that any mode we use on 472 kilohertz should be less than 100 hertz wide. I don't know why that came in. We didn't ask for it, but it's there if you choose to adhere to it. Although you could run SSB, there's plenty of room. But FT8, JT9 and Whisper are all in the WSJTX package from Joe Taylor. So if you download WSJTX, you've got them all. There was a longer form of Whisper called Whisper 15. I don't know whether that's still in WSGTX, but it was found that it didn't really have any great advantage over the 2-minute version, because in 15 minutes you can have a big QSB cycle and you know, you've wasted the extra time you spent sending. So and it goes over the Atlantic quite easily on 472 and 136, does 2-minute Whisper. So it's good. Another thing that is in use is Opera. This is a bit of a contentious one because it's written by the guy who wrote Ross. He seems to be a good one for causing controversy. Opera is contentious because when you transmit Opera, it flags up to a server on the internet that you are transmitting, when you are transmitting, and what your call sign is, obviously. So all receivers at the other end, listening to Opera, know that you are sending and can correlate what they're getting with this checklist of possible people who are sending at that time. So part of the signal to noise advantage is caused by knowing what you're listening for. But then, of course, you can ring up Bert and say, hey, Bert, I'm going to be put out a call on 136 at 8:30. Have a listen. So there's that aspect of it as well. I'm sure you'll come back in the Q&A and defend Opera.
Well, there's two modes, the decoder and the correlation pass on 477 136. So the first pass is decode,
Yes.
and then the next bit, you don't get the decode, it's correlation pass, which flags up as deep search.
Yes. So yeah, I mean, this is a point that people make, though. So yeah, fair enough. There's two passes. Of a single pass, but the first mode of the decoder sees if it can decode it clean, then it has a check to see if that is likely to be something that's there. So Opera is used fairly widely, and the last one is QRSS, which is not used much now, very effective, the good old mode that was invented by early LF operators, just using very slow CW and a fast Fourier transform, a waterfall display, in other words, to display the Morse. Remarkably effective. Somebody did a little chart comparing the efficiency of QRSS, very slow CW, with 12 words a minute Morse, which you would consider slow as DX operators, and about 25 dB advantage sending QRSS at 30-second dots. Now that's slow, isn't it? But that's what they use to get across the Atlantic. And a 25 dB advantage over 12 words a minute CW is well worth having. Okay, lastly, I've got a little bit about experimental modes that aren't quite in the forefront yet, but could end up there. First one, Eb0, which is Coherent Bpsk. If we get to the Q&A with time to spare, I'm sure Andy can explain a bit more about it. It's able to drill right down to the theoretical, almost the theoretical limit of information exchange in the noise on a path, but it does need extreme accuracy of timing so that your signals are indeed coherent with the receiver. It may not be quite so good on a fadey path. People are trying it on 136 where there is QSB, but it's been extraordinarily successful on VLF, and the most headline grabbing achievement was that DK7FC in Germany has been received an actual, I forget how many characters, was it three character message? Maybe has been received in Tasmania on 17 kilohertz. This is an amateur transmission with an ERP of a few microwatts, half around the world, using Eb0. So it's a remarkable thing, but it's not very easy for the uninitiated to use. So it does need someone to pull all the bits together and make a nice press this button to do that type system. There's another thing called WSQ call. I've underlined that's a QSO mode, that one. That might be worth a look at, ZL2 AFP. And I've just learned yesterday about this one, which is an augmentation of Ft8. So it's kind of a running joke that, you know, it's like buses or whatever. There'll be another one along in a minute. Another mode to try on LF. I don't know where anybody's using that yet, but it enables a little more freedom with your messaging, and you can ask people questions and get a response back with JS8. So for Eb0, find all the gen at abelian.org. That's Paul Nicholson's website. I think he's G8LMD, is that his call? I was trying to figure out what his call sign was. I know he's an amateur, but he doesn't publicise that. But Paul Nicholson's the brains. If you want to look at WSQ call, that's where ZL2 AFP has posted it. This will all be up on the web. We'll put this presentation up on the web on wireless.org and g0mrf.com afterwards. And JS8 call, who are these? Registered domain, much better idea, easy to remember. conscious we're overrunning already, so let's get over to receiving LF. Obviously you need an aerial. Most of us will use the bit of wire we got. E-probes are good, the little PA0 RDT style E-probe. There's one. Very small and quite amazingly effective. Or a loop like a Wellbrook or a tuned frame aerial type thing. Very good as well. Use it carefully, either of those. Orientate it so you don't pick up too much interference from local gubbins, or your wire aerial, obviously. And trouble with a wire aerial, it's going to bring in a lot of, well, any of these, they're all sort of broadband, they'll bring in a lot of other stuff. You will need front-end filtering on your receiver. And now we're going to talk about receivers, which will probably be a HF transceiver or an SDR. Same thing really, but SDR is more and more common, and they all seem to perform pretty well down on the bottom end of the band. But again, front-end filtering, very important. Otherwise you'll just get a load of aliasing and crud. Or maybe a converter. That used to be the way we would do it. So David G0MRF has been over to Martin Lynch, and he's tested a load of receivers and transceivers to see how they perform on LF. So I'll pass it over to him. Put this amazing thing on.
Oh, you're still attached.
Well, yes.
No, that's a bit of a challenge, isn't it? Okay, so I'm going to do a bit of an audience survey and just quickly ask our assembled guests here today, who has ever listened to either 136 or 475 kilohertz band, either to receive something, whether it be whisper, CW, or anything like that? So hands up if you've actually listened to those bands. Actually, that's really quite impressive. Okay, there's a significant number, a fairly high proportion, which is good. Okay, now let's take that.
I didn't hear anything.
Okay. I never suggested you would. Okay, let's take that percentage down a bit. Of all those people, who's actually transmitted on the bands? Okay, so a much smaller fraction. So getting people onto these bands is always a bit of a challenge, because as we've just heard, if you go there at the wrong time, or you don't search around, or your receiver is basking in local interference from the internet, the chances are, you're not going to hear something immediately that sounds like CQ worldwide in a couple of weeks' time on 20 meters. But the logical place to start with all of this is, in fact, with your receiver. Most of us will have amateur radio transceivers, and most of those will have a general coverage button on the front, allowing them to go down below top band. Now, if we have a look at a typical set of receiving apparatus, we've got commercial transceivers, dedicated SDRs. Interestingly, you can get on the band receiving with quite a decent performance by buying a soft rock for 630 meters, I think, $23. Quite amazing. Receive-only dongles, they do work down there. They tend to be overloaded by medium wave and other broadcasters. I understand that some of the web SDRs that are out at the moment actually use RTL dongles with the converter part bypass. So effectively, you've got a much higher performance direct sampling SDR, and they do work very well indeed. Of course, the internet, home-built kits, designs, up converters, transverters, all sorts of ways of listening to the bands. And then transmitting commercial transceivers, you're not likely to get anything coming out of the SO239 on the back of the average HF set. Only exception I've found for that so far is the IC7300, which generates about 8 to 10 watts. If you wideband it and tune down to 475 kilohertz, it actually works very, very nicely. Dedicated products, there's a few transmit converters and transverters out there, and of course the internet is bustling with all sorts of designs. The only thing I would say is once you've read the website and read how brilliant it is, find a few people who've built it and find out if that's really true, because sometimes beauty is in the eye of the beholder. So if we want to perhaps look at some of the things we subscribe to, most of us here will belong to the RSGB, a few of us will belong to the ARRL, will receive their relative offerings through the post or online. And if we look at a typical transceiver review, we'll find something like this when it comes to looking at receive performance. Radcom at the top from June 18, Peter Hart review. Peter always takes a great deal of trouble getting a lot of detail in. And if we look at the performance there for the receiver, we've got lots of HF bands, 50 megahertz, preamps off, preamps on, microvolts and dBm equivalents, lots of detail. If you come down to the ARRL, fewer bits of information about receive performance, but one important difference. The ARRL, despite the Americans only having the band for the last 11 months, have already, as a matter of routine, started including receive reviews of the performance of transceivers that they evaluate. So if you take the current edition of QST, flick around to the IC 7610 review, you'll find figures in there for sensitivity at 137 and 475 kilohertz. So I'm not quite sure. We've had the band for 20 years and it still doesn't feature in Radcom. I'm sure that didn't happen in the days when we went from AM to SSB, but a work in progress, I think, there. So I decided that as there was a lack of material already published, I would go and have a chat with my local amateur radio dealer, who fortunately sponsors this event here this weekend, Martin Lynch. His location is quite close to me in West London, and I picked a particularly good day to go and have a chat with him. It was his birthday, and when you're asking a big favour, it's better to do it in person, isn't it? So I said, Martin, I want to come around your showroom, test all the radios, put loads of wires across your shop floor. Can I do it? And I twisted his arm, and a few days later, I turned up at the Emporium in Staines with a signal generator, an AC voltmeter, and started to work my way around some boxes that I would never be able to afford, which was a real treat. So what do we do when we're looking for a set of receive figures? Well, I wasn't there for a lot of time. Dave provided information on about 10 transceivers. I managed to test about 10 at the same time. So we've got a couple of pages of results here, which I won't go through in detail, but I'll try and point out a couple of significant ways of how you can evaluate the performance of your radio by these figures. I did two things. First of all, I injected a signal to give S9 on the meter of the radio. Now, S9 is a completely arbitrary value. It varies widely from manufacturer to manufacturer, but it does do one thing. It allows a comparison between the radio on 3 different frequencies in this case. So I tried to check top band on 1830 kilohertz, 475 kilohertz and 136 kilohertz. And if you look at the figures perhaps at the top there for the ICOM 756 Pro 3, very popular radio, not in production anymore, but there's a lot of them out there. You can see the figure for S9 is minus 75 dBm on top band, and then on 475 kilohertz it goes down to minus 66. That's a pretty good indication that that radio automatically switches in a medium wave attenuator. And on most radios, you have no choice. It simply switches it in, and suddenly your receive performance goes down by a significant amount. I think it's probably about 10 dB on that radio. The important thing is, for looking at how flat the radio is, though, is the figures between 475 and 136. If you look at the Pro 3 again at the top, we've got minus 66 dBm for S9 on 475, and minus 64 dBm for 136. That's pretty good. That's within a couple of dB between those two bands. And bearing in mind some of our American friends have done a little survey of how much background noise there is on these frequencies, they've sort of estimated that depending on the particular day, you can have something like 8 dB more noise on 475 to 1830 on a really good day. And if the atmospherics and conditions aren't in your favour, the noise level, background noise level on 475 can be anything up to 24 dB higher. So a couple of dB here is actually really very good. To get a better indication, now I've also done some figures for 6 dB signal plus noise to noise. And that really isolates a few things in the radio that can actually be masked on the S9 readings. Again, looking at the 756 Pro 3, minus 122 dBm for 6 dB signal plus noise to noise. That's a little AC voltmeter plugged into the headphone socket. Reference level on background noise. Injector signal 800 hertz higher than the dial frequency, so you get a nice 800 hertz sort of CW tone. Turn the signal level up until you get a 6 dB increase. Minus 122, minus 114 on 630 meters, so there's your sort of attenuator coming into play. It directly subtracts from the signal to noise ratio, and 110, minus 110 dBm on 136K. That's actually quite good performance. And if you get a radio with really something on 136 kilohertz, perhaps better than minus 100 dBm for 6 dB signal to noise, it's doing reasonably well. And that's an example of quite a good radio. Coming down one, though, to the IC 7300, this radio took the market by storm a few years ago. We've got minus 110 dBm signal to noise on top band, minus 105 on 475, so it's still working quite well. Remember what Dave said, you'll probably need a filter, perhaps even a filter preamp on the input. But when we go down to 136 kilohertz, we're down to minus 87 dBm, which is a huge signal just to get 6 dB above the background noise. And actually what I discovered is that the IC 7300, with all its lovely FPGAs and things inside, creates a huge amount of noise in that part of the spectrum. So when you look at the specification for general coverage receive, and it says ICOMs go down to 30 kilohertz or 100 kilohertz, they do, but they don't tell you how well they work. So you need to really get the data. I won't go through those, but this will be on Dave's website and probably mine at the end of the weekend. I went through a number of ICOM radios, some Yaesus down here as well. Let's just go over the page here. FTDX 5000 MP. I couldn't pick it up, but it does work quite well. Again, fairly flat across the band. The only thing is you can't actually choose anything. You can't change the attenuation levels. You can't switch preamps in or out. That decision is taken for you by Mr. Yaesu in Japan, unless it's buried somewhere in some deep and distant memory that I couldn't find on the machine. So lots of different information. To summarize, what I would say is that the best performing radio we had here is actually the one Dave has at home. He has the ELAD FDM Duo SDR. If you look at that for S9, minus 71, minus 71, minus 71, absolutely flat across the band for S-meter reading. For signal to noise, minus 116 on top band, minus 116 on 630 meters, minus 115 on 136. I don't think you could really get much better than that, bearing in mind my measurement error was probably 1 dB anyway. In general then, I think of the major manufacturers here, Kenwood actually came out on top. All of their radios were consistently good performers right across that range of spectrum. ICOM came out a fairly close second, with the exception of their new technology radios, the direct sampling 7610 and the 7300, both of which suffer from internal noise problems. 7610 is not so bad because it's a bigger box, so they've probably increased the spacing, but that was a bit of an issue. And the Yaesus, generally work, but they were very inconsistent depending on the model. It seems as though there's a lot of redesign each time a radio comes out. So some work very well, some simply don't work at all. There was one, Ft857, I think. You tune it to 136 kilohertz and you get S4 of noise level on the meter. And it's almost impossible to get a signal to noise ratio on that because the background noise is so high. Anyway, useful information because it isn't yet covered by really RADCOM or QST. QST will do all the new things on the market, but this is a useful bit of information. So what else have we got to get us on the bands from smaller manufacturers? Well, if we have a look at this unit, this is produced by a company in Australia run by Roger, VK4YB. He runs a company called Monitor Sensors, and I guess this is the Rolls-Royce, or the Australian equivalent of Rolls-Royce. I don't know if they have a motor manufacturer that does that. This is a converter, a transverter, goes from 160 meters to 475 or 472 kilohertz. I believe there's a version of this for 136 as well, but it's a pretty eye-watering $600 US. But it's got nice features, firmware that's upgradable by USB, a fairly wide supply voltage, and I'm told this can even withstand 100 watts accidentally transmitted into any of the ports on the back of the thing, which I don't think I've ever come across a transverter that can do that. Probably doesn't want all the repairs being shipped halfway around the world. So anyway, very nice. Apparently on 16 volts, I've seen on some of the LF chats, this produces 90 watts output. That's a brave owner. Somewhat smaller, MF Solutions, run by a chap called John, WA3ETD in the States. Fairly simple, single FET up converter, so transmit converter here, available as a kit for $75, available ready built for $99. And it generates about 22 to 25 watts output. 136 kilohertz version is being developed. And a couple of years ago, I remember talking to Dave, and he said, well, what we really need on these bands is something that can generate a couple of 100 watts output for good old CW. And at the time, that was true. It's probably still true now. But with all of the modern WSJT modes, where we get significant coding advantages and bandwidth advantages, really 25 or 50 watts represents enough signal to be radiated to actually have QSOs across Europe. Possibly SSB across a town, not that I'd recommend it. CW, maybe out to 100, 150 kilometers, but JT9, this would work very nicely across Europe. Mini kits, another product coming from Australia, a transverter, available as a kit, about £70 to get all those parts in a bag from Australia. If you have a look at this, there's a fair parts count on there. Looking at it, there's a fair number of bits, and what it doesn't show you is that on the other side, there's about a dozen surface mount components as well, so get your eyeglasses out for this one. Again, I haven't read any reviews of this, but I notice, remember, whisper and those modes need quite high stability. Yeah? The input attenuator is here, so 5-watt resistor sitting there, and the crystal that controls the whole stability of the thing is almost right next to it. So I would possibly look at a review and find out that this is a good design before buying one. But very nice to see it on the market. We have our own manufacturer, Linear Amp UK, who've started marketing their Gemini HF1K amplifier. Apparently, it can provide 200 watts, over 200 watts on 472. When you have the little band select icon come up on the front, it actually has a little 472 kilohertz touchscreen button, which is wonderful to see somebody taking the band that seriously. Also available, from Italy, you can buy these pallet amplifiers that are already constructed and tuned, generally wideband. This company, ITB, I think it's Italian Technology Broadcasting, They specialize in VHF and medium wave amplifiers. So unsurprisingly, some of their products work very nicely at the lower end of medium wave. And they're updating the range constantly, so check the spec, but apparently these things have quite a good reputation for working, at least on MF, but not LF. I've also added a couple of my little projects in. Amplifiers on the right-hand side, a 300 watt class D amplifier. This has the quirk of needing to be driven at twice the operating frequency, because it divides the signal by 2 and then amplifies it in a couple of FETs. Here's one I've made earlier, so you can peer into that if you like at the end of the session. And on the left-hand side, a rather smaller amplifier, 5 watts output, a linear amplifier this time. Wide bandwidth, 80 kilohertz to 2 megahertz, with a space on the board for a low-pass filter of your choice. It's intended as a high-gain block for modern transceivers that have a little socket on it marked drive, yeah, DRV outputs on the back. They're usually a few milliwatts at best. This one, 6 dBm input, 5 watts output. It's probably quite an easy way to amplify if you've got one of those transceivers available to you. Finally, the internet is your friend. If you search around the internet, you can find all sorts of wonderful goodies for sale. Rally finds, top left, RF ammeters. This is a band where you can connect an ammeter in the antenna and see how much current is going up it. G3XBM transverter has been built by many people in the middle there. The GW3 UEP 100 watt amplifier, 100 watts from the smallest number of components I think I've seen. And occasionally you find very odd things that are hard to find. Last week, somebody put up on one of the reflectors variometers for sale. They're Litz wired, beautifully engineered, a little motor at the bottom so that the inner coil goes up and down so you can vary the inductance. There were 40 of these from an earthquake communications project in California. And they decided it wasn't such a good idea after all, having built it all. So somebody bought up the variometers and was selling them online. So, oh, it's gone in the opposite direction. What's going on there? So it's really time to get onto the bands. There are lots of things to do, lots of ways of getting on. You may already have a radio if you've got a 7300 that can do it all for you. And if you have a look on this sort of compilation of slides, you can see antennas vary from the very nice commercial tower that I get access to in the winter. Yippee, 104 feet high, that's wonderful. And something on the far side involving a drinks bottle with a loading coil on the top of a bamboo stick. And I managed to work Germany with that, 18-foot bamboo pole with a loading coil on top, ridiculous. Tesco's cheapest sparkling water, I think that one is. And in the middle here, we've got the QRS. I think we can read Echo Alpha 5 Delta. Oscar Mike is missing. And on here, some JT9 from G3KEV, one of the band's characters. And just here, we can see traces from Alpha Alpha, 1 Alpha, and N1 BUG on the eastern seaboard of the USA. So no excuse not to be on. We have a list of useful links, and with that, I think Dave is going to take any questions and perhaps have a bit of a debate.
Yes.
Let's swap over. There we are. Which one?
Let's go back to the links page while it's talking.
Yep. Okay.
Good thought. This is seamless, isn't it? Seamless changeover.
Repeats the question.
Right. Anybody want to join the debate? What would you like to come up with? Yes.
Quick question. When you were measuring the receiver performances there, you mentioned noises, FPGAs and stuff. What I'd like to know is, did you consider the power supply noise and any noise coupled through power supply when you were doing that? I found that was a very big problem when I played around with it.
A question was, did you consider the power supply noise when you were doing these measurements, David?
Okay, hopefully this microphone is wired into the. Okay, this is good. Yeah, the power supply noise was really eliminated by the fact that Martin runs all his radios from one giant power supply underneath the bench. So anything with an FPGA with it will get its power supply from the same source as all the other radios. So yeah.
Simon.
Yes, one comment. The AirSpy SDR is outstandingly good down at 472 and 136 kilohertz. If you get the latest firmware into that little radio, it is superb down there.
I've got one. I'll have to run these tests on it and
Make sure you
add
get-
them to the chart.
Get the
Oh, yeah,
latest firmware
okay.
flashed in.
So which is-
AirSpy HF Plus
Yeah.
performance reputed to be good on 472, but
Claimed by me.
claimed by
And
Simon.
can I ask, does that one include a tuner stage, so it converts, or is it direct sampling?
It's not direct sampling. It's a tuner chip, very heavily modified. It is as good as the Perseus, if not better, down there.
Perhaps not on high signal handling?
Yes,
So
it is actually beating the Perseus.
So high signal handling is okay on that device. Okay, thank you.
Is the 100 hertz bandwidth still in place?
Is the 100 hertz bandwidth limit still in place? Well, it's in the. It was in the original document. I think it's a kind of a European directive, but I don't think it's mandatory. Well, I'm hoping it's not.
The license.
No, quite. Not in the license, so I guess it's not in our license, it's in some people's license. So I guess if it doesn't say so in your license, I would have thought so. I mean, people have used SSB and whatever as just a quick try and other wider modes. I don't see what's wrong with it. It's not exactly crowded, is it?
There's also a 100 hertz QSO mode there.
No, I think that would be a spark transmitter would be explicitly forbidden.
Unless you keep it at 100 hertz.
Yes, unlikely.
I was intrigued in the difference between the 7300 and the FDM Duo, because they're both SDRs, and that one should have such better performance on LF than the other. Is that due to any filtering, or is it just completely as it is?
So the question is about the difference between two SDR-based radios, the IC7300 and the ELAD. Obviously, the ELAD does have very good performance that we've been able to measure. The 7300 doesn't seem to do that. Dave owns one, I own the other. Dave, is the decoding done purely in the PC it's connected to?
Not on the test I did, because the ELAD is a self-contained radio, so I just used it. I didn't use external software.
Okay, so my conclusion to that would be if one manufacturer can get it right and the other one sort of misses that opportunity, perhaps we can look forward to a firmware update from ICOM to sort out the situation. However, personally, I think it's noise inside the radio, and it will need a bit more than a software update, probably a lot more screening.
What's propagation like? I'm assuming it's normal. Better at night.
Better at night.
Grey line.
Grey line, definitely. Noise, as with all the lower bands. Very like, I always regard 472 kilohertz very like top band. Perks up no end at night. 136, there is a big enhancement, but it doesn't feel quite.
Big enhancement at night.
There is a big enhancement over the longer distances, because it's longer wavelengths, I suppose. But yes, they both perform better at night, but of course a lot more noise. You can hear thunderstorms from an awful long way away on 136 if you're keen.
And from an average person's antenna perspective, are you using sort of low inverted Ls, or what would you recommend as a starting point?
As much wire as high as you can get it is the simple answer, but people use anything like a top band. He's asking about suitable aerials for the band. Anything like an 80-meter dipole with a feeder strapped or something, that would be a good start.
So something like, I've got a double extended Z for 80 metres, it's 150 metres long, it's only 25 feet from the ground, it works.
It'll certainly work. Yeah, that would be a reasonable aerial. Not going to be... The thing about the way it's licensed is that we're allocated an ERP on 472 kilohertz. It's 5 watts EIRP. Now you can do a lot of sums and work out how much power you would have to put into that wire to radiate 5 watts EIRP. So it's up to you. If you want to build a kilowatt amplifier, stuff it up there, you can do it. You can be as loud as anybody else. I like that. I think we all ought to be ERP.
Interestingly, the American regulations limit the mast height to 200 feet and the output power to 500 watts. Any more questions? Let me ask you a question then. What is it going to take to get some of the people who listen on those bands to actually take the plunge and get onto it? What do you need to make that leap?
Might be the case if the sunspots decrease any more, lower.
Okay, so lower sunspot cycle, carrying on for years and years.
It has been interesting that the LF bands performance has been superb last few years. It's always been good. It hasn't suffered from.
Yes, I remember last winter I was able to listen to VO1NA, who admittedly is in Nova Scotia, and one night in 3 I could hear CW from him. So no fancy modes, a good old CW signal coming across the Atlantic, and he doesn't run kilowatts. You know, he's got maybe 100 watts and a fairly, I imagine, a fairly long antenna in Nova Scotia.
He has got a very nice piece of wire.
Yeah.
What about the big geomagnetic storm we've just had over the last 2 or 3 days? The A index was over 20. In the last few days, did that really hit things on 472?
It does. You tend to get an enhancement, and then you get a dip, and then it's.
At what stage as the A goes up, or?
I think we'll have to consult G3NYK on that one.
Okay.
He's the guru on all this, but you certainly do get a yo-yoing of the conditions, and they peak up very well. I'm not quite sure in what part of the solar event that happens, but there's certainly a big peak, and then there tends to be a bit of a doldrum. So you just
and
have
I've
to
seen
choose
some
your time.
research that suggests that after one of those events, solar events, the electron density in the ionosphere is maintained rather than dies away, and that causes quite a long, it causes quite a long tail before conditions return to normal. So that's after the peak.
Yes. Okay.
Well, with that, I think we're at 16 minutes past 2. Thank you very much for attending, and I hope to see some of you on the bands in the near future.